Yeah, no, we didn't. I did my first one.
Alright, here we go.
Make sure you both of the.
So, in your notes, last thing we had should have been. Give me a second here.
I can give those to you.
Well, I'm hoping you had the kinetic molecular theory from the video that the sub showed. It might have been a little hard to hear, but you should have had the notes from that. And I'll quickly go through some of those again real fast. So you should have had what the kinetic molecular theory is. That means all particles are in motion. Gases move in random straight line motion. They change paths when they collide with other objects or themselves and other particles. Their collisions are perfectly elastic, which means when they collide, they transfer energy, but the total kinetic energy of the system stays the same.
We're just going to do a test bell. There seems to be an issue.
All right, test bell. There it is. Works. Class is not over. Not yet. So you should have had that. So we just went over that with the homework. I'm going to move on because I'm assuming you got that. That's what I'm hoping. All right. Yeah.
What's that black thing right there?
That is the product. I should move this anyway. It's probably in the way. That's the product of a chemical reaction that you may or may not see. You'll see it this year at some point. But that's it. Okay. All right. So now what we're going to talk about is gas pressure and air pressure. Gas pressure and atmospheric pressure, air pressure. First thing I'm going to ask you is what causes gas pressure?
Does it have to do with the amount of particles there is and how big their space is?
Okay, the amount of particles and how big the space is. Good. So if you want to put air in tires of a car or truck, you keep pumping air into it, what's going to happen eventually?
Explode.
Yeah, a tire could explode, right? Pressure would be increasing. So that's good. More particles in a small area means more pressure. But what actually causes the pressure?
Gravity.
Gravity, good try. Not gravity.
Speed of particles.
That can change the pressure, but what actually causes it? That can change it. You guys know, you're doing good. How do you put pressure on the desk?
Push down.
Push down on it. How do you put pressure on the wall?
Push against it.
Lean on it. Okay, so I'm putting pressure on it. No pressure. Okay, putting pressure on the desk. No pressure. So, what causes gas pressure? Force. Okay, we're getting there. Between what?
Oh.
The gas and whatever it's in. Okay. So gas pressure caused by, let's not use force. We can use it, but I want to use a different word. Starts with a C.
Compression.
Try again.
That was a really good guess, though. Right?
It was a great guess. Instead of force. So particles exerting force, like particles doing that, that's creating force, right? Particles bouncing around. Collisions, that's what I want to say. Caused by collisions between gas particles and other gas particles, as well as collisions with the environment.
Combustion.
Bless you. I had to finish my thought. Now, when I say environment, it doesn't mean like, you know, trees and frogs and water and stuff like that. It can. I just mean wherever the gas is. If the gas is in a tire, the environment is the tire. If the gas is in this room, it means this room. So that's a loosely used term there. So collisions between gas particles and other gas particles, as well as collisions. Oh, I spelled it wrong, didn't I?
Yeah. Is this the same thing as like? Is this like the same thing as like a high pressure system?
What do you mean?
Like, you know, when a high pressure system comes in, or like weather?
Oh yeah, the
Is
air
it the same
pressure
thing?
will change. Yeah,
Okay.
high pressure, low pressure, right?
Okay.
If you ever watch the news, they talk about the pressure's increasing or decreasing.
So if it's a low pressure, it's like colder out, right? It's like a
Yep, low
cold front.
pressure, it's usually colder, high
All right,
pressure.
cool.
Yep. So, yeah, it's all about particle collisions with walls of their container or between themselves. So, what causes air pressure, or sometimes we say atmospheric pressure? What causes air pressure or atmospheric pressure?
Is that the actual one?
Well, no, not for class. Class is not over.
Oh, okay.
Well, that is.
But that's like the halfway.
Okay. Yeah, okay.
What causes air pressure?
Temperature?
That
Or
can
does it
change it.
Okay. This is the same thing?
Except,
It's there.
exactly. It's the same thing except
Okay.
with air. Caused by air particles colliding.
Well, aren't air particles just gas particles?
No. Technically, a gas is a compound or an element.
Oh, okay.
Technically. You could say, okay, yeah, air is a gas. Yes, it is. But air is made up of different gases. That's kind of a technical way to look at it. But yeah, caused by air particles colliding. How come we can't feel the particles colliding with our face?
Because they're too small? Or
Because there's a
not
lot.
enough power?
Is what?
There's a lot happening, so you wouldn't really know.
When do we feel air?
Wind. Wind.
Okay, good. When do we feel air pressure change?
My kneecaps every
Your
single
ears?
week.
What's that?
In my kneecap.
In your
Every
kneecap?
single time the weather decided
Okay.
it wants to rain.
Is that actually true? Because I feel like
It hurts so bad.
No, some people
I'm not even
ache
kidding.
when the
Because Gigi
pressure
always says
changes.
that.
Because you're an old lady.
I am an old lady. My knee kills me
Young
every
old
time
lady.
the weather changes.
It happens.
Because I smashed it on the floor.
Ears. Explain ears.
Your ears pop and you go
When you go where?
like
Airplane, right. Or up a mountain or down a mountain, right? You can feel the air pressure change. That means the collisions are changing, okay? So we're going to talk more about air pressure actually tomorrow, but I just wanted to relate it to this. We're going to focus on gas pressure a little bit today, but it's important to remember this. The only thing that really causes gas pressure is right here, collisions, which helps you understand why if you pump more air into a tire, the pressure increases. Because what are you increasing? There's more particles in a smaller area, so they collide more often. Therefore, pressure goes up. So that's a really important concept. Memorize that. Collisions are what causes gas pressure or air pressure. And again, we'll talk more about air pressure tomorrow. All right. So now what I think we're going to do is I'm going to talk about how pressure is related to temperature and volume. So Devin and Ryan were talking about how temperature can affect pressure, so can volume. If we have a big open space like this with lots of gas in it, the pressure is going to be kind of low. Why?
Because it's like more spread out.
More spread out. But if we were to
Has more
shrink the
room.
room, if we could seal all the windows and doors, say it's airtight, and then shrink the room, what would happen eventually?
It would get like a lot of pressure.
Yeah, lots of pressure. We would be squeezing all those air particles, all right, and the pressure would increase dramatically. So pressure, temperature, and volume are all related, but I want you to understand how they're all related. Our next lab, it's called Boyle's Law and Charles' Law. There's 3 gas laws. It involves pressure, temperature, and volume. So what you need is a scrap piece of paper that you are not going to keep. You're going to recycle this paper. It's just for a little in-class activity.
Should we have paper?
Full piece. I guess it could be half. It could be half, I suppose. Yep, you want to share, it could be half.
How did you do that?
I have no idea.
That was amazing. How
No, I just ripped it out.
did it.
I couldn't tell you honestly. I think mine has like, mine has like indents in it. Or no, what happened was, on one of these pages, I was drawing like really heavy on the side, so it has like an indent. I'll find it.
Okay,
Maybe it's just how it is.
write that on your paper. PTV. Pressure television.
Dude, I watch that all the time, you know.
Does it have to be that way?
Dude, that's my favorite TV show.
Technically, no. Pressure, temperature, volume. That's what you're going to do, PTV. And what I want you to do, and this, some of you are going to get it real fast. You're going to be like, all right, this is dumb. The point is not that it's super exciting. The point is to see something and manipulate something to help you remember it. That's the point of doing this. So I get it. You're going to understand it pretty quickly, but it's important to see it. So what you're going to do is take a pen, poke a hole right through the middle of each letter. Pen or pencil. So right through, stick your pen right through. Right in the middle of PTV. Don't stab yourself.
Let's do that. Oh, I get it. This makes sense, huh?
So, here's what you're going to do. Stick the pen or pencil through the T. Okay. Hold the paper sideways or horizontal so they all look kind of like that. Okay? I mean, in retrospect, every time I do this, I think, oh, I could just do it myself and you guys can watch, but I'd rather you do it with me. All right, so now here's the part to learn. Pressure of gases, temperature of gases, volume of gases. They all work together and they all affect each other. So what we're doing is we're taking one variable out of the equation with the pen. So the pen is holding temperature constant, kind of like this room. Temperature's constant. The only two variables we can change are pressure and volume. So if we have a sample of gas and we can alter the pressure and or volume, when we change the pressure and or volume, the other one changes accordingly. What does that mean? If temperature is held constant on a sample of gas and we force that gas to be more dense, we push the particles close together, we increase the pressure. So rotate your paper up. Don't twirl it. Follow me. If we increase the pressure, what happens to the volume? The volume decreases.
Okay, I see.
What happens if we increase the volume? Pressure decreases. I know the letters get all squirrely, but that's okay. So if we increase volume, pressure decreases. So what's the relationship between pressure and volume? When one goes up,
the more pressure, the lower.
When one goes up, the other goes down. What's that called? Indirect relationship. One goes up, one goes down. Take your pen out. Hold it sideways. I want you doing this with me. Okay. Put it in the pressure. So this should be facing you. You don't need. I don't need to see it. Okay. Now the pen is through the pressure. Pressure is held constant. Notice what happens if I increase the temperature. What else goes up? Volume goes up. What if I decrease the temperature? Volume goes down. No matter what temperature does, volume does the same thing. What's that called? A direct relationship. Last one. This is the one that kids are always like, I get it. It's stupid. Put it in volume. They're all horizontal at this point, meaning nothing is increased or decreased yet. If we increase the temperature, what happens to pressure? Right, if we heat up a gas, pressure increases. What if we decrease the temperature? Pressure decreases. If you increase temp, pressure goes up. Decrease temp, pressure goes down. What's that called? A direct relationship. So these three variables play a big role in what happens to gases. So don't throw these out. Okay, you can recycle them. Don't throw them out. Not yet. Not yet. Keep them at your desk. Here's what we're going to do. We're going to draw three graphs. Three graphs. You got time. Three graphs based on what we just learned.
In your notes or on that stupid?
In your notes. In your notes.
Is this enough room, or should I put it on the side?
That's fine.
Wait.
Oh, the bottom.
Okay.
All right. So now here's the part where some of you who like to take neat notes are going to hate me. But I want you to do it anyway. I want you to draw three graphs based on what we just saw.
All right.
constant temperature. So temperature doesn't change on that graph. This graph at constant pressure. So pressure is not a part of that graph. And then this one is at constant volume. So volume is not part of that graph. So I want you to label your X and Y and show me what the graph looks like, a line graph. We just went through the relationships, direct, direct, indirect. So there should be two that are direct and one that is indirect. Because we just said that, right? We just went over that. So I want you to go ahead and sketch it. I'm going to go and walk around. And check it out.
I don't want to mess it up because that's gonna look.
Yeah, no, but you got it. You got to try. There's no way to learn anything unless you make a mistake once in a while.
So now I don't remember because.
Yeah, I don't remember.
Did the pressure?
Label your axes first.
So the temperature goes up, so does the volume.
Label your X and Y axis first.
Okay.
Maybe I should help you with that. So at least you have that. So this one's going to be volume here, pressure here. And if you're, oops, I spelled way off today. If you want to switch those, that's okay. Some classes, they make a huge, huge, huge deal of independent, dependent variable. This is independent, this is dependent, X and Y. It's not as crucial to me. It's the relationship I care about. This one, temperature. Temperature always goes on the X unless it's with time. So that's easy to remember. Temperature's always there. And volume is here. And then constant volume, you would have temperature here and pressure here. So again, that's what they should be. If you kind of started doing it and you got these flipped, it's not the end of the world, but now go ahead and sketch your graph. If you didn't crumple your paper up, you could use it to help you. Too strong.
It was a good shot.
Paper just
Yeah,
crumpled
I'll throw
under your
yours
hand.
into it.
I didn't even squeeze.
I know, it's scary.
All by itself.
See, some good things.
Thanks.
You gotta give it a shot, even if you have to cross it off and do it all over again.
I have not.
Like,
Yeah, I can make it from here.
Yes.
Don't do it right now. So you should have two direct relationships and one indirect relationship.
I got both.
What are you doing?
I got both.
Let me see.
Nothing happens. Nothing happens.
All right, talk to your neighbor about it.
all right, neighbor.
Talk to your neighbor.
I think this one just goes like this. Bam.
Talk to your neighbor.
No, what?
No.
What if we just cancel out?
Zach, talk to
Really
Charlie.
nothing happens.
Yeah, nothing happens. That's
Maybe if the
not-
temperature. No, because if the temperature increases, so is pressure and volume.
So that's
No, it's not.
That's
It's
not
not
true.
true.
It's
You got the
incorrect,
same
bro.
thing. Did you talk to Blake? You gotta talk to somebody.
Okay, I think what happens is we should wait for
Talk
this
to
one
Shelby or Blake.
I think.
Help her out.
Just doesn't
Come on,
matter.
Blake, help her
That's
out.
what we're just gonna say. Good answer. Alright. Work on 3
1, 2, 3, great.
Yeah. So remember?
You guys figure it out?
Yeah, easy.
So like,
Easy peasy.
This is light work.
Say
This
right there. Talk to each other.
it's the
Did you
constant.
compare?
Yeah, they
Compare.
So like,
is light work.
as
What?
That's what
You lost?
dentist
Maybe
is.
she lost in a different way. Maybe she's not.
as volume decreases, pressure
like what?
increases. So it can't be a giraffe, which is like that's correct. It has to be.
I don't know if
like,
Karen.
Yeah. Okay. So that makes sense. So then as pressure decreases,
Me and Charlie have the same thing, Devin.
okay. And then
That's
as
why you're talking to her.
volume
Not- This
increases.
isn't like official. This is like.
Is there?
Yes, of course. When I'm you can hear me.
I know the answer.
Interesting.
Charlie.
Mission
So
Boy.
it's one increases.
How do you want me to shoot it? Hold on, quick shot.
All right,
Yeah, scream it.
look up here.
Yeah. No, I can do
Next time we do the whole pairs thing, I think I might actually have your desks get together. Some of you don't really take part as well as you should. So if you look at this, if temperature is held constant, pressure goes up, volume goes down. That's this one. Temperature is held constant. If I increase the pressure, what happens to the volume?
It goes down.
It goes down. That's called indirect relationship. What does that graph look like?
A circle.
Lovely graphs.
No.
Let's think about it.
Not a
If we
circle.
have a high pressure and we have a low volume, okay?
A straight line.
If we have a low pressure, we have a high volume.
Box.
I'll pick up with that tomorrow. For now, live in suspense. You won't be able to sleep tonight thinking about these. I know it.
Oh yeah.
No, thanks to geometry, it's really helping me out.
I hate it.
So did I. So that